Just like the equations with square roots, we're going to start by circling the variable, drawing the line, and boxing the square. All right, so we want to get that square by itself before we can get rid of it. Once we do that, once we get the square by itself, we're going to get rid of the square by taking the square root. This is where things get a little bit different, though. In step 3, when we get rid of that square, we're going to be writing two separate equations. We're going to be writing one with the positive square root and one with the negative square root. Once we have those two equations, we solve them like we normally do. This is a pretty basic one. We actually did a problem in the opener that gave us the exact answers to this. I wrote down an equation that looks like this in the opener, right? You guys remember that? Yeah. So let's go through the steps that we're going to do to solve this. So we're always going to start by circling the variable and drawing the line. And then since this one has a square in it, we're also going to do what? Box the square, right? So that's the first thing it says in step 1. Now we're not going to box the square by doing this. That's not what I mean by box the square. All right, the square is not just that exponent, not just that 2, but it's also what's being squared. And what's being squared here?
A.
The a. So our box around the square is going to look like this. The box doesn't really do anything for us in this problem because there's nothing outside the box. All right, it's going to be the more complicated problems later where this box is going to be helpful. It's going to help us identify what we need to start with. So in this one, since there's nothing outside of the box, our goal is to get rid of the square. And how do we get rid of a square? We take a square root, right? So a square root is the opposite of a square. So we're going to put a square root over the top of the square. So we're taking the square root of the left side, which means we need to take the square root of the right side. Once we do that, we're going to simplify. On the left side, how do we simplify it? What happens? The square and the square root, those cancel each other out, right? What does that leave? A. Now, on the right side, this is, again, where things get a little bit tricky. On the right side, when we do the square root of 25, we're looking for a number that multiplies by itself to get 25. What can we multiply by itself to get 25? 5 or negative 5, right? So 5 squared is 25. That's going to be one of our answers. But then we're always going to write or, and we're going to get a second answer. So we could do 5 squared to get 25, or we could do negative 5 squared to get 25. So we get two answers here. It's not okay to just write a equals 5 or negative 5 and just write the negative 5 next to it, because when the problems get more complicated, this is not going to be the last thing we do. All right, if you look at step 4 that you wrote down, it says solve both equations as usual. We don't have to solve these equations because A is already by itself in both, but that's not always going to happen. All right, so when that doesn't happen, if we just write A equals 5 or negative 5, it's going to make things a lot more complicated for us. So we're going to write two separate full equations, and since A is by itself in both of them, we're done. So how do we show we're done? Box it. Circle a variable. We want to get that B by itself. So to get B by itself, we're going to have to get rid of two things, right? The square and the negative 1. So we circle a variable, draw the line, and then we're going to box the square. So remember, boxing the square is boxing not just the exponent, but what is being squared. So the box around the square is going to look like that. Notice that the minus 1 is not in the box. Why not? It's not part of the square, right? Okay, so since we have something outside of the box, what do we have to do first?
Get rid of the
Yeah, we've got to get rid of everything that's outside the box first. That's what this is reminding us here. So we're going to get rid of that minus 1 by doing what? Add 1. All right, so we add 1, add 1. Yeah, now we simplify, right? So the minus 1 plus 1, they do what? They cancel. What does that leave on the right side? B squared. On the left side, what's 3 plus 1? 4, and equal sign goes on the line. All right, now the square is by itself. So now that we have the square by itself, we get rid of the square by doing what? Taking the square root. All right, so we're going to take the square root here. That's going to get rid of the square. But if I take the square root on the right side, I need to take the square root on the left side. All right, so now we simplify. When we simplify this, on the right side, the square and the square root cancel, right? And what does that leave on the right? B. On the left side, when we take the square root of 4, remember we're looking for a number that multiplies by itself to get 4. What's it going to be? 2 or negative 2. So we're going to put 2 in here, and then we're going to write a second equation, and we're going to have a negative 2 where the 2 was. All right, so we have 2 equals b or negative 2 equals b. Because 2 squared is equal to 4, and negative 2 squared is equal to 4. All right, again, in both of these equations, kind of like the first example, we're done because the variable is by itself, right?
Yeah.
So since we're done, let's box them. Okay, circle a variable, draw the line of equality, and the last one's box the square, right? Now, we're not going to box the square like this. We're going to box what's being squared. Is it going to look like this?
No.
No, why not? That square is on the parentheses, right? So since the square is on the parentheses, we need to box the whole parentheses. So our box is going to look like that. That box is a reminder that we have to get rid of the stuff outside the box first. Is there anything outside the box that we need to get rid of?
No.
No. So we can go straight to getting rid of the square. And how do we get rid of a square, Michael? We take the square root. So we're going to take the square root here. And since we took the square root on the left, we're going to take the square root on the right. And now we simplify. When we simplify the left, what's going to happen? Michael? The square and the square root cancel each other out, and that leaves d minus 4, right? On the right side, when we take the square root of 25, we're looking for a number that multiplies by itself to get 25. What's that going to be? 5 or negative 5, right? So we're going to have two equations again. So we've got or. This time when we write our second equation, what's it going to be? We're going to have equals negative 5 on the right side, but what's the left side of that second equation going to be? Still going to be d minus 4. So these two equations that we write here are going to look the same, except one's going to have a positive 5 on the right side, the other one's going to have a negative 5 on the right side. Now, this is the first example we've done where we actually have to solve two equations, right? So let's just focus on one at a time. This d right here, how are we going to get that by itself? We're going to add 4. So we add 4, we add 4. We cancel the 4's out. We get d on the left, and we have 5 plus 4, which is 9 on the right. We've got our equal sign there. So one of our answers is going to be 9. Then we're going to go over here on this one. We're going to draw our line of equality there, and we want to get d by itself there. If you want to, you can circle the d there. You don't have to. But we do need to get that d by itself. How are we going to do that? We're going to add 4. It's actually going to be the same thing that we did on the other one. The difference here is that we're adding 4 to a negative 5 instead of to the positive 5. So when the 4's cancel here, we still get d by itself on the left. But then on the right side, what's negative 5 plus 4? Negative 1. To finish this up here, we're going to put or between our two answers and box it. In the last couple of examples, we've gotten the same answer, but one positive and one negative, right? That's not necessarily always going to happen. Sometimes when we have more than just the variable and the square, we're going to get two completely different answers. All right, so if we were to check our answers here, we put 9 in for d. If we put 9 in for d, we have 9 minus 4 is 5, and then we square it. What's 5 squared? We get 25. That one works, right? If we put negative 4 in for d, I'm sorry, negative 1 in for d, what's negative 1 minus 4? Negative 5, and what's negative 5 squared? 25. And that one works also, right? So since they both work, we need to give both answers. So remember, there's three things we're going to do to set it up. We're going to circle the e. We're going to draw our line of equality. And to get e by itself here, there's a 4, a 17, a 2, a 3, and a 3. There's a bunch of stuff we have to get rid of, right? All right, so these circles and boxes, these are going to help us decide what to get rid of in what order. So this box around the square here, notice that it's not around the 3 on the bottom, because the 3 is not part of the square. So what do we have outside of the box that we need to get rid of? Yeah, both of those 3's, right? Are we going to get rid of the divided by 3 first or the minus 3 first?
The minus 3.
We're going to get rid of the minus 3 by adding 3. So let's add 3 to both sides. 3's cancel. And we simplify. When we simplify the left, everything stays except for that minus 3. So we're going to rewrite almost the entire original problem. So we're going to have 4e minus 17 in the parentheses. That parentheses is squared and then divided by 3. And on the right side was 0 plus 3? 3. Okay, now we still had that divided by 3 that was outside the box, so we need to get rid of that. How are we going to get rid of it divided by 3? Multiply by 3. So we multiply by 3, multiply by 3. On the left side, those 3's cancel each other out, so we have everything else left. 4e minus 17 squared equals 9. Okay, that's it of the stuff that was on the outside of the square. Can we get rid of the stuff that's inside the square? Not yet. Why not? Because it's inside the square. So we need to get rid of that square. How do we do that? Take the square root. Thinking I might run out of space here. Okay, so on the left side when we simplify, square and square root, those cancel each other out. What does that leave? 4e minus 17. On the right side, remember this is where we get two answers now. The square root of 9 could be what? Positive 3 or negative 3. So we're going to put positive 3 here. We're going to write or, and we're going to have the same equation, but we're going to have a negative 3 in there. So 4e minus 17 equals negative 3. So we'll add 17 to both sides here. On the left side, 17's cancel. We get what? On the left side, 4e. On the right side, and then divide by 4. We get 4. I'm sorry, 4's cancel. We get e equals. What's 20 divided by 4? 5. So there's one of your answers. E equals 5. But now we need to go over here and solve and get our second answer. What are we going to do to get e by itself here? Add 17. I know I ran out of room too. Just do what you can. You can go down into the problem below it if you need to. So we simplify here. We get 4e equals. You guys are going to love this next part. What do we do next? Divide by 4. What's 14 divided by 4? Yashua's on it. We get e equals. We're going to leave it as a fraction because 14 divided by 4 is a fraction. It's it's a decimal, right? 3.5. But we don't want to write it as a decimal. We want to leave it as a fraction. But what can we do with 14 over 4? We can reduce it by 2. What's 14 divided by 2? 7. What's 4 divided by 2?
2.
Put or between your answers and box it.